Recording in progress.
I was telling you that there are three states. We are discussing the
Yeah.
water that is in the liquid state, in the ice, and in the form of water vapors. Now they have mentioned that the cooling curve and the heating curve are not same. They will not be same. Okay, there will be
Yeah.
difference in the cooling curve and the heating curve. And why is this so? Why cooling and heating curve is not same? Why?
Because what's it called? They have like different energy.
Yes, it depends on the it depends on the
Yeah.
particles, nature of the particles. Like if
Yes.
we when we discuss the heating curve, right? In the heating curve, we
Mhm.
started from the solid. Okay, we started from the solid. Like the particles were like this. Particles were like this, and then we go till gas. In the gas, the particles are far away from each other. Okay.
Mhm.
And then when we talk about the cooling curve, we started from this, from gaseous side, right?
Yes.
So they both are
Yes.
opposite to each other. This is what they have mentioned, that why they are different, because it depends on the particles, how particles are arranged. And in the cooling curve, the cooling curve starts from gas or from solid.
From gas,
Yeah, and in gas, what is the particle, what is the arrangement of the particles?
far apart, like very far apart.
Yes, they are far apart from each other. And where it goes, the cooling curve, where it ends?
At solid.
Yes, at solid, in which particles are uh, closer to each other, right? Then there is about the forces, that what is the forces in the, when we talk about the solid, and what about the gaseous state?
But
Intermolecular forces. I am asking about the intermolecular forces.
uh, intermolecular forces are what's it called uh, um, strong in um,
Yeah, in case of solid,
heat.
firstly, in case of solid, what will
Yeah.
be the magnitude of the forces in the solid state?
I don't know.
Hmm?
I'm not sure.
They will be strong, in
Oh
solid.
yeah. Okay. Okay. I thought like you asked for a number.
No, no, no. Magnitude is not just like I am just asking you that they will be strong or they will be weak in terms of that.
Yeah. It will be weak in solids.
In solid, intermolecular forces are weak. Are you
No,
sure?
strong.
They are
No,
strong,
strong.
right? So
Yeah.
what they're saying in this sentence is that if you start from the solid, like if we talk about the cooling curve, right? And cooling curve, we in the cooling curve we start from the gas, then we have liquid,
Yes.
and then solid. And what is the particle arrangement? The in the solid, the particles are close to each other, right? The particles are close to each other,
It's close.
and in the gaseous form they are far apart from each other. This is particle arrangement. And what about the forces? In solid you have strong intermolecular forces, right?
Yes.
And in gas you have weak intermolecular forces.
Weak.
Yes,
Yes.
this is about the cooling curve. This is about the cooling curve.
Yeah.
And when we talk about the heating curve is exactly opposite from this. From where
Hmm.
we will start heating curve?
From a minus
From the gaseous state or from the solid state?
solid. Solid.
Yeah, that is ice, right? Then you have
Yes.
liquid, and then
Then gas.
gas. So what will be the particles arrangement? The particles in the solid are
And
close to each other.
closer.
Yes,
Yes.
closely placed. Then in the gaseous form they are far apart.
Far apart.
Yes. What about the forces? Intermolecular forces?
Strong
Yeah,
and
in
solid.
solid they are strong, and in gas they are weak.
Weak.
So you see how we can compare these two. So these two are exactly opposite from each other. The heating curve is starting from the solid, the state is solid, and the cooling curve is starting from the gaseous state. So this is what they have mentioned over here, that they both are different for each substance. For each substance they are different because it depends on the particles arrangement. It depends on the arrangement of the particles, how particles are arranged, and in the solid, in the liquid, and in the gaseous state, and what are the forces in them. Okay, it depends on these two things. The cooling curve
Yeah.
and the heating curve, they both depend on the arrangement of the particles and the forces between them. Are you clear?
Yes.
The heating curve on the right is for iron. This is for iron. They have mentioned. You see this heating curve. It starts from the 0 degrees Celsius. There is no negative temperature, and you have it. It goes till this at F 3500 degrees Celsius. Now, what is your task? You have to tell me. I am marking this. Okay. You will tell me where is melting point for this and where is boiling point. Which point? This is point 1. This is point 2, 3, 4, 5. From A to B it is 1. From B to C it is 2. What is the melting point over here? Look into this. Melting point.
Wait, I can't see your screen. Okay, now I can see it. The melting point would be B to C.
Yes.
No, no,
Yes.
no.
You're right. This
Yeah,
is
yes,
B to
yes,
C.
B to, yes, yes, yes,
Because it is
yes. I thought,
constant for few minutes the line is constant, right? It means that at this
yes.
time the okay, how you will figure it out? Firstly, you need to check. We are starting from here, right? We are starting from the A. It means,
Hey, yes.
and this is heating curve. From where heating curve start? From the solid or from the gas?
Solid.
Yeah, it starts from the solid, right? So you have over here you have solid, right? Then there will be liquid state obviously somewhere, and then in the F there will be gaseous state. Okay, once you
Yeah.
figure out this, then you can know that okay, this was solid. Now you are increasing the temperature. You are increasing the temperature. What will happen? The solid will start to melt, isn't it?
Melt, yeah. Yes.
And for melting there will
Uh,
be a few time.
yes.
The temperature will
And
remain constant for a few
D
minutes.
to
Yeah, so this is
D to E, it will be boiling.
melting point.
D to E, it will be boiling, yeah.
Yeah, it will be boiling, right?
Yes.
It is boiling point. Why it is boiling point? Why it is considered as boiling
Because
point?
it's also constant
You
for a
will say,
longer
at this the
period,
temperature is constant for few minutes.
few minutes.
After melting, once this iron is melted, now you see at C the iron will melt. This is melted now. Now you are further increasing the temperature. So when you are increasing the temperature after when it reaches to maybe 2750 degrees Celsius, okay, till at this temperature, the time at this you will say this temperature will remain for few minutes because this is known as the boiling point. Okay,
Yeah.
are you clear with this graph? What is happening
Y-
and how the solid is converting into gas?
Yes, yes.
This was solid. At this stage you get the liquid over here.
Liquid.
This at this stage you will have liquid. Then from B to C it is melting. From D to E it is
D to E.
boiling. Yeah.
Gas.
Yes, gaseous form.
Gas.
Okay. This was about a pure
Boiling, and it
substance
will
like
give us gas.
sorry. What you are saying? Rohan?
Recording in progress.
Okay, what I was telling you.
Yes.
Yeah. Now we will see one more thing about the purity of the substances. That there is, you see, these two graphs. There is nothing. They didn't discuss about any impurity in it. These two graphs, the cooling curve and the heating curve for water, as well as this graph, they all are showing the pure substances. Okay, what is a pure substance?
Mm-hmm. Oh,
What is a pure substance? Any idea about anything?
okay. I think it's like where you use metal and water.
No, no, no. Just simple idea. What is a pure substance? Like if you have anything pure, what comes in your in your mind when someone told you that this
It
is a
will be
pure thing?
clean.
Hmm?
It will be clean.
Yeah, it will be clean. It will have no impurities in it, right? No other things are
Yeah.
mixed in it. So that is a pure substance. A pure substance is basically a substance which is made from only its own particles. Like for example, if we talk about the water, if we talk about water, you know, water is made up of hydrogen and
Yes.
oxygen, right? Oxygen and hydrogen gas. So these two gases
Yes.
will combine to form water. I'm talking about the pure water. If we talk about the
Yes. Yes.
pure water. Okay, so this is the composition of water. Similarly, if we talk about any other thing like the carbon dioxide gas, that is made from the carbon and oxygen, right? That is made
Mm-hmm.
from carbon and oxygen. So this
Yeah.
is what we are saying, a pure substance. A pure substance has only one type of particle, only one type of particle, and it has sharp melting and boiling point. This you should mark on your book, that the whenever you have a pure substance like pure water and pure iron or pure carbon dioxide, anything, they will have sharp melting and boiling point. What is meant by sharp melting and boiling point? There will be no range. There will be no range.
Mm-hmm.
What is meant by this? Like for example, what is melting point of water?
Which
The melting point of water is 100 degree or
the
0
melting
degree.
point of water is 100 degrees.
That is boiling point. Melting point is
Oh, 0.
melting point is 0 degree, right? So it is 0 degree. There is no range. Like we are not saying it is 0 to 1 degree. We are not saying this.
Yes.
Why we are not saying this? Because we are talking about pure water. Okay, we are talking about pure water. In pure
Mm-hmm.
water, you don't have any ranges. The melting point and the boiling points are sharp. They are exact values. Sharp means the exact values. Okay.
Yeah.
But if you have impure water, like there are some impurities in the water, then you will have a range. Okay, then what will happen? The
Mm-hmm.
water will not boil only at 100 degree. Maybe it can boil at 98 degree. It can start boiling at 98 degree and it can go till 110 degree. Okay, so this happens when you
Mm-hmm.
have impure substances. Are you getting my point? What I am saying?
Yeah.
That whenever you
Yes.
have
Yes. Yes.
any substance that is pure, pure means it is made up of only from its own particles. There is nothing other added in that.
Mm-hmm.
In that case, that substance will have sharp melting and boiling points. Okay, that substance will have only sharp
Yes.
melting and boiling point. There will be no range. But if you have any substance, any impure substance, like there is something added in the water, you know, the impure water, like oil, for example, oil is in the water, so its boiling point and melting point will change. Okay, clear?
Yes.
Just like, you know, the milk.
Yeah.
In milk you have water, right? And you have other ingredients as well in milk. So the boiling point and melting point of milk is changed from the water, and it has range.
Yes.
Okay, if it because milk is made up of, it is a mixture and it can have some impurities in it. So whenever you have a pure
Yes.
substance, just keep it in mind that the pure substance will always have sharp melting and boiling points. Clear?
Yeah.
Okay. But if other But if other type of particles are mixed in it, if other particles are mixed, what will happen?
It will be impure.
Yeah, they affect the forces between the particles. Actually, why it is so? Because the forces are now affected. Okay, let me write it on the notebook because it is becoming more messy. Okay, what we are discussing is that when you have a pure substance, right, in pure substance you just have the particles of that substance, particles
Mhm.
of that particular substance only. Okay, like for example, you
Mhm.
have water. If we talk about water, in water you have hydrogen gas, right, plus you have oxygen gas. You have these two gases. So, and you know the boiling point of water is 100 degree, while
Mhm.
the melting point is 0 degree, and these two are
0 degrees. Yes.
sharp values. What is meant by sharp, melting and boiling point? That if, even if you have given the, for example, you have given it the temperature of 98 degrees Celsius, it will not boil at 98. Okay, it will not boil at 98 because it is a pure substance. We are talking about pure substance,
Yes.
and it will not melt at minus 1 degree, it will not melt at 1 degree. Okay, it will just melt
Mhm.
on at 0 degree Celsius. This is what we are
Yes.
discussing, and this is what is meant by sharp, melting point and boiling point. Are you getting this? That what is meant by
Yes.
sharp? Sharp means the exact values. The values cannot change. If you increase the temperature or if you decrease the temperature, the water will, obviously it will go beyond the boiling point, but the boiling point is 100 degree. Okay.
Mhm.
Then if you have impure substance, when you have impure substance, it means there will be, what you will have, you will have the particles of that substance plus some other particles. Okay, which are making that particular thing impure. Just like, you know, the tap water is impure, that is not pure water because we can't drink the tap water, we just drink the
Yes.
filtered water. And okay, in
Yes.
impure water there is, for example, let's say we talk about the water. So in a beaker, you have water. In that there is water, plus there are sodium ions as well, there are chloride ions as well. Okay, there are some other ions as well. So this one is what, this is an impure water. Okay, this is impure water. I am writing water like this: H positive ions and OH negative ions. Okay, this is impure water. In this case, what will happen now? The melting point and boiling point values are not sharp. Okay, in this case you will not have the sharp values of melting and boiling point.
Mhm.
Clear? Like this, yeah,
Yes.
it can boil before 100 degrees Celsius, like it can boil at 98 degrees Celsius. Okay, it can melt at
Mhm.
minus 1 degree Celsius. This can happen because why it is so, because it is an impure substance. In impure substance you don't have
Mhm.
sharp values, but in a pure substance, whenever you have a pure substance, that pure substance will always melt and always boil at its own sharp melting and boiling points. Are you
Mhm.
clear with this?
Yes.
Okay, then we have yeah, this is But if the other type of particles are mixed in, like for example, if they are talking about the impure substances, that some other type of particles you have mixed some other type of particles, what will happen? They affect the forces
It
between
will.
the particles. The forces will be affected. Why? You know why is this so?
Mhm.
Because if you just look into the pure water, you have this hydrogen and oxygen, right? There is just covalent bonding in it. There is covalent bonding. Clear? Because they are sharing. But now in this
Yes.
case, when you have impure
Mm-hmm.
substance, there will be some other type of bonding patterns as well. Okay, there may be
Okay.
van der Waals forces. Okay, I'm just giving you the idea what can be the forces. There
Yeah.
can be van der Waals. We can write the hydrogen bonding will be there. Actually, in water there is hydrogen bonding. There can be covalent bonding over here. There can be covalent bonding over here. Okay, the
Mhm.
sorry, the covalent bonding, the hydrogen bonding. There can be ionic bonding in some cases as well. Okay, so this is what we are discussing, that in impure substance the bonding pattern changes. Okay, there are different bonding. Why there are different bonding? Because you have more particles in impure substance. So obviously when you have different
Mhm.
particles, the bondings will be different. But when we talk about the pure substance, like for example water, in the pure substance you have hydrogen bonding. Okay, you just have hydrogen bonding when you have pure water. So it means when you have just one type of bonding pattern, it is clear then that you will have fixed sharp values. Are you getting this? When you have just one type of bonding, you will have sharp melting and boiling point. Okay, it depends on the substance. If the substance is pure, obviously that will have a particular type of bonding, and when that substance have a particular type of bonding, in that case there will be, it will have sharp melting and boiling points. Clear? And
Yes.
on the other hand, if we talk about the impure substances, in impure substances, as there are more particles, as you know there are more particles in the impure substance, so obviously there will be different bonding patterns as well. And when there are different bonding patterns, so the boiling and melting point will not be sharp. There will be a range. Okay, you will say there will be a range of melting point and boiling point,
Yes.
that it can start from the 98, it can boil at 99, it can boil at 100 degree. Clear?
Mhm.
Okay, now they have mentioned this. Changing of states will now occur over a range of temperature. Okay, in this case, when you have mixed substances,
Mhm.
that is what they are saying. The changing of state will occur at range of temperatures, not sharply. So lines
Mhm.
like B, C, like from B, C, then D to E on graph will be tilted. In this, the lines are straight. Why these lines are straight? Because these are the pure graphs, the graphs of the pure substance,
Mhm.
right? They are talking about the pure iron over
Yeah.
here. But now they are saying if you have
Yes.
impure iron, what will happen? The lines will not be straight, they will be tilted. Are you getting this?
Mhm.
Why the lines will be tilted?
Yes. Yes.
Because in impure substance you have different bondings, and due to that different bondings, you don't have sharp melting and boiling points. Okay.
Mhm.
Now read from this line, from the graph. Here are for pure water and iron. Start reading from here.
The graphs. Okay. What is the substance is not pure?
That is impure
The
substance.
graphs here are for. Yeah.
You will start from here. The
The
graph.
graphs here are for pure water and iron.
Hmm.
A pure substance has only one type of particle, and it has sharp melting and boiling points, which you can find from the heating curve.
Yes. Are you clear with this? What they are saying? That the sharp melting and boiling point. Every pure substance have sharp values, right? Every pure substance have
Yes.
sharp values, and from where you can
Mhm.
get these values, these sharp values, you can know about from the graph, from these lines, right? These lines
Yes.
confirm you
Yeah.
the melting point and the boiling point of the pure substances. Clear?
Yes.
Now read from here, from the second paragraph.
Okay. But if other types of particles are mixed and they affect the forces between particles, changes of state will now occur over a range of temperatures, not
Yes,
sharply. So things like B, C, and D, E on graph will be tilted and flat.
flat. Okay. Why now? I can ask you why you don't have the sharp melting and boiling points when you have a mixture, when you have an impure substance. Why is this so?
Like,
Hmm. You will say because in a mixture the melting and boiling occur over a
mhm,
range of temperature. Okay. And why it occurs over a range of temperature? Because the
yes.
bondings, because there are different bondings in impure substances. Okay, let me write it over
Mhm,
here. I can write, then you can take the screenshot. Or like we say, in impure substance, or mixture, the melting point and the boiling point are not sharp because there are some other particles present as well,
mhm,
due to which there are different bonding patterns. There are different bonding patterns. Okay, in impure substance, the melting and boiling point are not sharp because there are some other particles present, and those as well, due to which there are different bonding patterns, and thus
mhm.
the substance will melt or boil at a range of temperature. Okay, are you clear with this statement?
Yes.
Now, can you
Yeah.
tell me in your own words that why we are saying that the impure substance or mixture, why they don't have a sharp melting and boiling point? It is an important question. You can mark it.
Because the particles are, because
Hmm.
what's it called? There are some other particles that can be in there as well, and
Hmm.
due to that, the
Hmm.
different particles will bond together, and the,
Hmm.
and
There will be
the
different
pattern.
bonding. Yeah,
Yeah.
there will be different bonding patterns, and due to that, the substance will not melt and boil at.
Switch,
Hmm.
yeah, boil at the range of temperature.
Yeah, it will only boil at, it will boil at range of temperature. You don't have, you know, if you just have one bonding pattern, if you have just one type of bonding pattern, then you can say that the substance will boil or melt at sharp temperatures. Just like for example the water, when we talk about the pure water, so when you have pure water, you know exact values. It boils at 100 degrees Celsius and it melts at 0 degrees Celsius, right? Why is this so? Because in pure water you just have hydrogen bondings, right? But when we talk about
Yeah.
the impure water, so in impure water, definitely there will be some other bonding as well. There can be covalent bonding if there is another substance. There can be ionic bonding if you have ions in the water. So those bondings will definitely affect the value of the melting point and the boiling point. They will change the melting temperatures and the boiling temperatures. That is why we say that the impure
Mhm.
substances, they have a range of temperature. They melt at